Lesson 10.4, picking up where we left off yesterday. Let's see. Yesterday, we got as far as talking about if there's one radical. So when there's one radical, our job was to isolate the radical. So we got the radical by itself, and then we squared both sides. Today, we're ready to pick up of, okay, what do we do if there are two radicals in the problem? And I talked a little bit about the end of class that if there's two radicals in the problem, we're going to get one on each side. And then guess what? We're going to square both sides. So that's what we're doing if there are two as opposed to one. As you look at this first example, notice how it's set up. Square root of 7x minus 4 equals square root of 5x plus 10. A square root on the left, square root on the right. So it says what? Get one on each side. We have that, one on each side of the equal sign. So what am I going to do? Square both sides. Meaning I'm going to take both sides and raise them to the power of 2. What happens when we square a square root?
It's the original thing.
Okay, it's whatever's you get whatever's under the radical, right?
Yeah.
So when we square the square root, we get 7x minus 4 equals, when we square the other square root, we get 5x plus 10. And now we have a typical equation with variables on both sides. That's nice, isn't it? We just get to work it. So what do we want to do here?
Get 5 over to the side of 7x.
Okay.
So
X is on one side, numbers on the other side. So if it's a positive 5x here, to move it to join the other x, we're going to subtract 5x. 7x minus 5x is 2x. We still have minus 4
and 10.
equals, and we still have 10 on the right. Now I've got all my x's on the left. We want to get all of our constants or numbers on the right.
Yeah. So bring the minus 4 and 4 both sides.
Okay. It's minus 4. I'm going to add 4. Carry down the 2x. Minus 4 plus 4 cancels. 10 plus 4 is 14.
So, okay, 2x equals 14, so divided by 2 to get x by itself.
Divide by 2.
So, x equals 7.
X equals 7.
Okay, that doesn't.
Don't forget, same thing as yesterday. Be in the habit in this lesson of checking your answers, which just means I'm going to take 7. I'm going to put it into the original problem that had the square roots in it. So if we put it on the left, 7 times 7 is 49. Minus 4 is 45. And I'm just going to leave it as the square root of 45. So I'm just kind of, write it down off to the side if you want, but it's just kind of mentally in my mind. Square root of 45. Now I'm going to plug in 7 on the other side. 5 times 7, 35, plus 10, 45, and it's under a square root, which I already had square root of 45, didn't I? So square root of 45 equals square root of 45, which checks.
Checks out.
Okay, but that's the mental check I want you doing. And if you need to write it down, you can. But you can also just kind of do it mentally. Okay, let's try one more of these before we go to the bottom part. Square root of 3m minus 6 equals square root of m plus 2.
Okay, square both sides.
Okay.
Square roots are right.
We have 2 square roots.
Yeah.
1 on each side, so it's already set up for us. So we square both sides, meaning raise to the power of 2. What happens when we square that square root of 3m minus 6?
You get
Okay, we get what's under the radical. So we have 3m minus 6 on the left. On the right, we have m plus 2. Variables to one side, numbers to the other.
Combine 3m with m.
Okay. Combine 3m and m. How do I move this positive m across the equal sign? Subtract m. What's 3m minus m?
3. I don't know.
No.
3m squared.
No.
I don't know.
Okay, think 3m minus, what's the invisible little number here?
Oh, 1.
3m minus 1m.
3m minus 1. Oh, 2m.
2m. You're right.
Okay.
3m's minus 1m is 2m. We still have a minus 6 equals 2. If it's 2m minus 6,
Add 6.
add 6. 6's cancel. We have 2m equals 8. Divide by 2. And m is 4. Put the 4 in check real quick.
Sure.
3 times 4, 12, minus 6, 6. And so that is square root of 6. Put in 4 on the other side. 4 plus 2, 6, and that is square root of 6. Guess what? It checks. Didn't really need to write anything down for that one. Okay, so we've talked about one radical. We've talked about two radicals. Now, we are going to talk about, we're going back to one radical, but the key is there's more than one x in a lot of these problems. Okay, notice there's an x under the radical, there's an x outside the radical. X under the radical, x outside the radical. In these situations, we often get extraneous solutions. Okay, notice the first part of extraneous is extra, and that's what I try and remember, is that it's an extra solution. So when we talk about extraneous solutions, an apparent solution that does not satisfy the original equation. So we will often, sometimes just one, but we might get two equations here, or excuse me, two solutions. When we get two solutions, one of them might not work. So it's an extra solution. This is where the check is necessary, because you could get two solutions and one or neither of them work. Now, rules are still the same though. On this first example, there's one radical. What do I do?
I don't know.
What did we do yesterday at the top of the page? If there was one radical, we had to isolate the radical, and then we'd square both sides. Meaning, is this radical the only thing on this side of the equation?
Yeah.
Yeah, it's just the square root of what's underneath it. So we're ready to jump right into squaring it. If we square one side, we square the other side. What is x when we square it?
X squared.
X squared. Which is what brings the whole different twist into this problem. What is the square root of negative x plus 6 squared? Negative x plus 6. In the previous ones, we had to get x's on one side, numbers on the other side, but all the x's were just x to the first.
Yeah.
Here we have an x squared. Do you remember? When we have x squareds, We solve a little differently usually.
I did not
Trying to think with that. See, that would have been in last chapter actually,
yeah.
because that was more the quadratics. Instead of getting some on one side, some on the other side, make this equation equal to 0. When you have that x squared and that x term in there, make it equal to 0. And I like to keep a positive x squared, so I would move the negative x in the 6. So how do I move a negative x? To move the negative x over, we want to add x. And to move plus 6 over, we want to subtract 6. So to my x squared, I'm going to add x and subtract 6. So now my equation becomes x squared plus x minus 6 equals 0. How do we solve? Once we have a quadratic equal to 0, what do we usually try and do in this form?
Add 6.
No.
Wait, no. I don't know.
We want to keep it equal to 0. Here's my hint to you.
Oh, yeah. Jeez. Okay.
Does parentheses mean something?
Yeah.
We're going to factor it into 2 parentheses.
Yeah.
What do we know goes at the beginning of each parenthesis?
X.
Yeah, x squared is x times x.
Yeah. And then the x minus 6.
How do we determine the numbers?
Add 6.
Oh.
Well,
Think in terms of product and sum.
yeah.
2 numbers to give me a product of the negative 6, so the C value, and a sum of, what's the number in front of x? 1. So what numbers multiply to be negative 6 and add to be 1?
3 and negative 2.
And I can go for that. 3 and negative 2. 3 times 2 is 6. Positive times negative makes it negative. And a positive 3, negative 2, yep. So put those in your parentheses. I'm going to have x plus 3 in one parenthesis and x minus 2 in one parenthesis. What's my final step for the solving portion here? If we have 2 parentheses that multiply equal to 0, take each part and set them equal to 0.
Yeah.
Okay. So 2 pieces that multiply to equal 0. We're going to set each part equal to 0. So we're going to have x plus 3 equals 0 and x minus 2 equals 0. And then we're going to solve these. If it's x plus 3, subtract 3, and x is negative 3. If it's x minus 2, add 2, and x is positive 2. What's my final step?
Which one satisfies the original equation?
Yeah, check your solutions. Okay, so this is where you're putting both of them back into the original problem. Do we need a visual or can we, I don't know. Maybe I'll kind of, so if I put -3 in, -3 goes in for x, right? Equals square root, of -3.
Yeah.
So negative of -3 plus 6. Well, that really, negative of -3 is 3. This really is the square root of 9. But here's the deal. Can this square root equal a negative in the equation setting?
No, square roots can be negatives.
Okay, so a square root is only a positive square root, so we get 3 equals -3, which does not work. So right there, 3 does not work. Don't just assume 2 works. Try it, because there are often, yes, one works, one doesn't. There are random occasions where both work or neither work. So we're going to try 2. So 2 in for x is 2 equals, and then square root of negative of 2 plus 6.
Okay.
Negative 2 plus 6 is 4. Square root of 4 is 2. And then we come up with 2 equals 2, so 2 does work. Are we okay with how we check those? Okay. And it's really going to be, honestly, I'll be honest, the top part of the notes, I was just trying to get you in the habit of checking. These ones where the x is outside the radical, and you know, when you square them and stuff, those are the ones where they're likely to have answers that don't work. Okay. Shall we try the next one?
Yes.
Excuse me. Okay, there's one radical in the problem. What do we do?
Get it by itself.
Get it by itself. So how are we going to get it by itself?
Subtract 6.
Okay, so to move the positive 6, let's subtract 6. So then I have negative square root of 2x equals 4.
And then square.
Okay. And there's a negative out front of that radical. I'm fine with considering that radical to be by itself. And if not, we could divide the negative away or whatever. So I'm fine with that. So the radical's by itself. Let's square both sides. Okay. What happens when we square that square root?
You get what's inside of it.
You get what's inside of it. What happens when you square a negative? Because we also have to square that negative.
You get a positive.
A negative times a negative is a positive, so this is just going to become
16.
positive, well, positive 2x on that side. And then 4 squared on this side is 16. If 2x equals 16,
Divide by 2.
divide by 2. And x equals 8. What's final step?
Check it.
Check it. Okay, if I check this, 6 minus the square root 2x, so 2 times 8 equals 10. 6 minus 2 times 8 is 16.
Yeah, 16.
The square root of 16 is 4. 6 minus 4 is
2.
2. And what does that tell me?
But it doesn't work.
2 does not equal 10. So 8 does not work. 8 was my only option. Guesses?
No solution.
Yep, no solution. When you rule out all possible answers and there's nothing left, we say no solution. One more?
Yep.
One radical?
Square.
It's by itself. So we're going to jump right into squaring it. I square the left, I square the right. When I square that square root,
You get what's under it.
you get what's under it. When I square that x,
X squared.
x squared. So 2x minus 1 equals x squared.
Make your parentheses.
Make my parentheses after I do what? I can't factor this until I have everything on one side of the equation.
Yeah.
Okay? I agree, we are going to want two sets of parentheses. We are going to factor it. Totally agree there. But we need to make the equation equal to 0 first. I like the positive x squared. It makes factoring 100% easier. So I personally may keep the x squared here.
Okay. Yeah.
And then subtract the 2x and add the 1. So then I officially end up with 0 equals x squared minus 2x plus 1.
Okay, now
Now I'll take two parentheses. X squared goes to x and x. What numbers?
Sum of 1 and no. Okay. Product of 1. Sum of -2.
Product of 1, sum of -2. What multiplies to be 1? 1 times 1. The only option here is 1 times 1. If it multiplies to be 1 and it's positive, how do we get it to add to be a negative? They're both negative. So -1, -1. How do I finish this off?
Check it.
What's my answer though? I can't check it yet. I didn't write my official answer. Maybe you did.
X equals -1 and x equals
Well, it's not x equals -1. We're going to take x minus 1 and set it equal to 0.
Oh, okay.
You're going to have the wrong sign if you do that too soon.
Yeah.
So officially we're going to set x minus 1 equal to 0, and we're going to set x minus 1 equal to 0. However, they're the same thing, right?
Mm-hmm.
So it doesn't, solve either equation. The answer you get is x equals positive 1, right?
Mm-hmm.
Now we can talk checking. So if I check the square root of 2 times 1 minus 1 equals x, which is 1. 2 times 1 is 2. 2 minus 1 is 1. The square root of 1 is?
Can't do it. It's weird, doesn't it?
Are you sure?
I don't know. It's just 1.
Just 1.
Okay.
1 times 1 is 1. So the square root of 1 is 1. So what's that tell me?
That it works.
This works, doesn't it? Our answer is 1. Okay. The homework is in lesson 10.4 in Math Excel, of course. I don't know if you started it any last night or not, but
I don't think it did.
and I didn't look. I'll be honest, I forgot to look. So see what you can do with that and come back with questions tomorrow.